Today we're going to take a quick look at the difference between the GL and the GL texture outputs and how we specify their output position within the area of your window or your screen. Okay, so first of all, let's get our old favourite running. Let's get a rectangle, so generator rectangle. Let's get a window, so that's GL or window. Let's plug that one in, like so. Let's turn the window on. Now you'll notice that when I scale my window, my media within that window also scales, my white rectangle. In fact, what we'll do, let's bring some texture into here. So I'm going to just open my browser. Let me just go to my media folder. There we go. Let's bring that one in. So it's going to put it in the right wrapper for me. I'm just going to connect that to the rectangle input. There we go, just so it's a little bit nicer to look at. Okay, cool. So, as I mentioned, you'll notice that my texture will scale, and it will try, depending on the letterbox, on the sizing mode, it will either scale or crop or stretch or whatever. Now, quite a lot of the time, when you've made a generative patch, you want to be quite specific on your output, and you want to actually know 100% where your texture is going to fall within the output. So why do we see the differences with GL and texture outputs? So just to explain a core difference, and this is really a difference on the way on the graphics pipeline. So when we're working with the GL components, we are working in what we call vectors. So nothing has been set to specific pixels. Everything is in a variable 3D space. And it's after the vector stage that we rasterize our image and we create solid pixels, the pixels that we come to know in our final video file, our image file, or even on our output. So while we're in vectors, we're not locked to pixels. If you've ever worked with pixels in something like Photoshop, you'll know that you can't draw in between the pixels. You can either draw on one pixel or the next pixel. Whereas with vectors, they don't have that limitation, and it's once they're rasterized that their position is turned into pixel data. So when we're in the GL world of things, when we're in a yellow pipeline, we're in this vector world, and we're in what we call a UV space. So if you think of how our texture is applied to a 3D model in AI, it's a series of coordinates. Now the slight difference here with 3D models, our top left is 0, 0 and our bottom right is 1, 1. Now in OpenGL Windows, 0, 0 is the center, so the top left is -1, depending on the output of your window in fact, but your top left corner will be towards -1, -1, and your bottom right corner will be towards 1, 1. The value might not actually be correct, it depends on the ratio of your output screen, but positive numbers towards the northwest, and positive numbers towards the southeast, and negative numbers towards the northwest. Okay, so let's say that I don't want my output to vary like this. I want it to be fixed. I want to know that it's absolute pixels. So we have actually very briefly seen these modules earlier that we're going to use, but we didn't use them directly for this. We're going to use the clear module and the render to texture module. As I mentioned in the other tutorial, the clear is essential with the render to texture because it lets us prepare each frame individually and clear the memory once we've finished with a frame. So both of these are going to be in the OpenGL section because they're on my yellow pipeline. Render to texture, and then the clear module as well. So my clear goes into my render to texture, and my clear takes the output from the rectangle, and then I want to actually convert back from green to yellow. So I'm going to use another rectangle here, which might seem counterintuitive, but it's just the way it works. So So we're going to go green into there and then yellow into there. Okay, so now there we go. Okay, so because I've left this module on size input, you can see that it's still varying in its size, and that's because it's looking at the window at the end of the chain to determine what resolution to render at. So what I'm going to do, I'm going to insert some number boxes into my math vector join section because I want an X and a Y resolution. I'm going to choose two number boxes, so controller constant, and then right click on those, load alternate skin and text. Just take two of those. I'm going to write 640 in one, 480 in the other. We can place those in to the vector. Let's bring those just over there to make it a little bit more easy to understand, and then connect the output of that to my size input. There we go. And so now you saw the actual size of it vary there. There you go. So I'm actually able to specify my output resolution within my window size there. So that's a really handy tool if you want to actually be very specific on your output size. Give that a double click and you'll see it's only ever going to show at that resolution that I have specified. So it's a really, really useful tool there, and it can also allow you to sort of essentially bake your components into certain positions. So if you've got a lot of components made of vectors, sometimes when you play them on a screen of a different ratio, you'll find that their position will change because they're using those UV coordinates. So using the render to texture will essentially allow you to bake and solidify their positions within your composition.